Broadcasting from the Any Hour Services Podcast Studios, I'm your host, Mike Wilson, and you're listening to In the House. In the House is a podcast about the major systems in the house. Electrical, plumbing, heating, air conditioning. Each week, I'm joined by a panel of experts. We pick a topic and we discuss it in depth. It's meant to be informative, it's meant to make you smarter and hopefully bring you some value. In this episode, we're going to be talking about AC annual maintenance, what to expect, when's the best time of year to get it done, and why do we have to do it every year? So I've got Kevin, Dustin, and Dick with me today, HVAC managers at Any Hour Services. Welcome back, guys.
Thanks.
Good to be back.
So in episode 11, we actually talked about spring prep, and we went over a bunch of maintenance that people can do themselves. So tell me, what's the difference between the stuff that people do themselves and what a technician would do?
A lot of it's having the right tools.
Okay.
So if you don't have the right tools, you're not going to be able to do some of the stuff.
Right tools and the right know-how to know how to use the tools and to know what to look for.
So why do people need to do this each year?
Make sure it's running right.
I'm going to push back. Like if it's working, it's working.
That's a thing that we see a lot of times is it's maybe working, but it's not working as good as it should be.
It's keeping the house cool.
Yeah. Well, is it keeping it cool, or is it running longer than it should be?
I'm comfortable.
Okay. Is your utility bill comfortable?
It comes out of the bank. It's equal pay. Like, I got the money to cover it.
Okay,
like,
so you're not
I'm
paying
cool.
attention to it then?
No.
Okay, then. So if I came to you and said, Mike, I can lower that payment by a simple thing, what would you say?
I'd say do it.
All right, then.
So a big part of it is...
but I've had my air conditioner tuned up. My power bill doesn't go down.
Okay. And that you're lucky to have that because we don't see that a lot of times.
How does that make me lucky?
That you don't, your air conditioner's been running good.
Oh, but that
you haven't been overpaying for it.
Got it. Okay.
So a big part of it is you have so many moving parts and so many things that are happening on the inside of the system. When things move, they can wear out, right? You've got a lot of these parts that as they're starting to fall below manufacturer specs, they can create extra unnecessary strain and wear on other components. You know, for example, you got capacitors, right? If you find that a capacitor is actually running below spec.
Hit the mic and there's like a bass noise that happens. So
Nice.
Don't do that.
Sorry. What was I saying?
You were saying that you were too far away from the mic.
Am I too far? I get a frog in my throat. I'm sorry.
Ribbit. Capacitors. Things are moving. Things wear out.
So if you're running your system and say your capacitor is below spec, it's going to create extra work, for lack of a better way to say it, for your components that it's helping the motor and the compressor, right? And so it can just create that, which can cause those things to actually wear out and break sooner. And so having things checked because of all the stuff that's going on can prevent you from having to spend extra money on major repairs or replacement in the future prematurely.
That was one thought I had, Mike.
Closer on the mic.
Closer on the mic, Mike.
Or instead of bending down, actually bring the mic to your mouth because you're going to go
Got it.
back to a comfortable position.
Thought.
Yep.
You mentioned that you've had your tune-up and it didn't change the cost of your utility bills.
Correct.
Now, that may be something that occurs out there with other people as well, but one thought on that is maybe your utility cost isn't changing much, but maybe you're extending the life of your equipment by years. I don't know how many, but maybe you're extending the lifespan of that air conditioner, which is going to save you a significant amount of money without even recognizing it on your monthly utilities.
Yeah, and I'm just playing devil's advocate
No, I
here
like
because there's a lot of skeptical people out there. I'm surprised at the number of people that don't get it done. Now, I'm always under the impression when I talk to people that the reason they're not getting it done is usually because it's just slipping their mind, because people don't usually argue with the benefits of maintaining a large piece of equipment. And when people ask me, why do I need to have it done every year? one of the things that I tell them is that the people that engineered this thing, that are a whole lot smarter than me, that know how to get the most life out of the thing, have said, here's the things that you need to do on a regular basis to this. And so I relate it to a car, changing the oil in your car. It's pretty common knowledge. Like, more people know that, like, hey, every 3,000 to 5,000 miles, I got to get my oil changed in my car, but not as many people. It's not as common to know that, like, once a year I need to have my air conditioner tuned up. And so part of the reason that I go on the radio and talk about this stuff really is to kind of educate people and let them know that this thing needs to be done. But, changing the oil, rotating the tires, having all of those services done, the car manufacturers, they say, hey, these big parts are going to wear out if you don't get it done, and you're going to be putting more money into repairing it. And so what you guys said about, like, that's the thing, is when you don't maintain it, it's just like if you skip an oil change, the car's not just going to break down on the side of the road, especially when it's new, right? They're built to be robust, and they're going to keep going. And you don't usually recognize the consequences and the negative effects of neglecting that annual maintenance till years down the line. And then at that point, how many years did you knock off the end of the furnace, or how many extra dollars are you having to invest in repairs, Kevin?
So I like your comparison with oil changes. The difference is, with an air conditioner, you've got stuff. So an oil, take a look at your car. Most people know, hopefully, that if you're looking at a car and you're looking at the tires, for example, and you see they look smooth and bald, there's probably an issue with the tires. Or, a lot of people know that they can go and they can check their own oil, pull the dipstick and look at the oil, look at the level, and they have an idea of what to look for. Air conditioners is a little bit different because most people have no idea. There's no external things for you to just look at and say, oh, well, that looks bad. I mean, short of the actual coils on the outside, right? The condensing coils. When they get dirty, you can say, okay, that's an issue. But there's internal stuff, internal workings that just, there's nothing, no indicators. With your refrigeration, all your refrigerants and stuff that are running through there, it can be charged improperly, and it can run and it can feel like it's cooling the house, when in reality it's actually damaging the inside components, right?
I'm glad you're bringing this up, because I've always used that oil change analogy, but I would agree with you that it's more like checking the filter and like looking for those visual things, and it's the simple thing that you may be able to do yourself. But then when you go and actually have a tune-up done on the car, and you're talking about gap and spark plugs and the timing belt and all of these different things that can keep the car running, but if the timing's not right, or you've got a gasket that's loose, and you've got an oil leak, or different things like that, those can actually cause more damage. It looked like you guys were going to say something.
I was going to say something. Were you?
No, I saw you raise your hand. I'm glad we brought that back. I was starting to wonder how come the hands were being raised earlier.
When I was 16 years old, brand new driver, my dad put me in a vehicle to drive, and it was a newer vehicle. It was within 3 years old. And I'm 16. I don't know. Like you say, we've got to educate people on what should be done. I didn't know you had to have your oil changed. I didn't know there was a sticker in the window that I needed to worry about. And I just kept driving. It was just out of sight, out of mind. And my dad wasn't driving it, so he didn't see the sticker. And the engine blew. And awfully expensive. I remember it was many thousands of dollars. Now I'm an old guy, so that was, how many years ago was that? I won't even try to count, but a lot. And pretty difficult thing for my parents to recover from, to actually have to go buy a new engine for that vehicle. So the car analogy is very real. The fact that air conditioners could blow the same as the truck did.
So the car one is just so easy, I think, for people to understand, because so many people have cars. Because one thing that people will ask is they'll ask about the age of the system, and like, hey, if it's newer, do I not need to have this done? Is it more important when it's older? And I'll actually talk about a car and say, okay, well, let's look at the maintenance that you do on a car and the different ages of the car and the why behind you doing it. One, when the car is brand new, the reason that we are so on top of, even cleaning it and making sure that we're doing the oil changes and rotating all the tires and things is that we want that thing to run like new for as long as possible. Then once it gets a little bit older, the reason that we're doing the maintenance and having things things checked out is that we don't want any surprise breakdowns. We're still trying to keep it like to run as good as possible, but we know that it's getting some age on the thing, and we don't want the inconvenience. How inconvenient is it to wake up in the morning and not have transportation to work? The battery's dead, or, you know, the thing won't, the starter's gone out, or things like that, right? You don't want a surprise breakdown, so you're trying to stay on top of that. Now, when it gets older, it's a whole different reason. The reason that you stay on top of the maintenance is because you're trying to squeeze every drop of life out of that thing, because you know that you don't have or don't want to spend thousands of dollars getting a new one, and you're really trying to figure out or not trying to figure it out, but you realize that maintaining the thing, doing the maintenance, is the least expensive way to try and extend the life of the car. Your air conditioner is no different. So regardless of the age of the system, but talk to me about, are there things as the system gets older, like, is it more important to worry about it as it gets older?
Of course it is. Some of the things you want to make sure it's working great is you want to make sure you have the right refrigerant levels. Really, you never should have to adjust those things. You want to make sure the fan is spinning the right speed, because if it's not spinning the right speed or there's a blockage, it's going to cause that to overheat. And just like an engine, same thing, overheat, it's not good. An air conditioner is the same way. You don't want that to overheat. And
we actually have a copy of our air conditioner tune-up that our technicians can go out, and I do want to like go through every single step on there to like let people know, you know, the kinds of things that they should check and the things that why they should be looking at those things. But let's talk before that more in general. What should people expect when a technician comes out to perform a tune-up or a inspection or like a checkup? Like, different people call it different things. Tune-up is the term that Any Hour Services uses to describe the manufacturer's recommended maintenance and inspection items that need to happen every year. But what should a consumer expect when they're paying someone to come out and perform this annual service?
To be thorough.
Okay. How are they going to know if they're being thorough?
Man, that's a tough one, because they're not going to know all the things. I mean, we've got this list like you talked about. We're going to make sure and go through it, and we'll leave a copy with them. But there's a lot on here. We just want to make sure not to miss anything. Make sure to check every little thing on it, like talked about refrigerant, airflow, amps, electricity, capacitors, everything. We want to make sure that thing is running like it should be.
I've got an opinion on this, but I want to hear, do you guys, what should a consumer expect when a person comes out to their home?
I think that it's important for them to expect honest feedback on the state of their conditioner at that moment, right? Mm-hmm. I mean, that's the whole reason you do this, is so that you can know. I mean, it's like me. Do I want to sit here blissfully ignorant of an impending thing that's coming, or would I like to know and be able to hit it head on? You know what I mean? Mm-hmm. If I hit it head on, knowing that that's going to be way cheaper than if it does end up actually hitting me later, And I think that's what I would hope people could expect, is an honest breakdown of where it's at that moment.
Okay.
I think another thing they should expect is recommendations. We might be there for just a tune-up, but what we're doing is we're looking for things that could make your equipment better. You go in for an oil change and they sell you windshield wipers. It's the same with your air conditioner. We're going to come and look at things, and our job is to educate you on the condition, but then if there's things that we can do to help you improve, we're there to make recommendations so you can choose whether or not you want to improve your system.
I agree with you. My opinion is, when someone comes out to your home and you're paying them to do this inspection or this tune-up or whatever they're doing, you've got a certain level of knowledge of how the system should work. And I'm along the lines with Kevin. Like, this should be an education. It shouldn't just be an exchange of money and you taking the word of the person saying like, hey, I did this stuff. Like, they should be able to prove to you that they did it, and that's usually done in the form of a conversation, education, and an important part of that also, I think, is a written report. They should be documenting everything that they're finding as they go along, so that if there are questions, they've got it, and it's not just like, oh, I think it was this, I think it was that. They have data that shows here's how it is, because the manufacturers publish data about like, hey, here's the way your capacitor should be functioning. Here's the voltage or the amps or the electricity, all of this stuff. Here's what it should be. If it operates between this and this, A and B, then it's good. If it's operating at C or Z, you should probably you should think about changing it. If it's D or Y, the thing is probably going to be going out soon. You know what I mean? Mm-hmm. And so knowing, and I heard someone say, and I think this is a good way to explain it. All we're doing when we go out there, one of the things that we're doing when we go out there to perform this tune-up is we're looking at, here's the way the system is engineered and designed to perform on day one when it's brand new. With dirt, voltage changes, vibration, all of those things cause that system to get a little bit further out of spec. We're documenting how far out of spec it is. If there is cleaning and adjustments that we can make, then we make those things, but sometimes parts just wear out, right? So we're showing them the difference between that, and as to Dustin's point, we're giving recommendations to try and get it back as close to that as we can. Does that make sense?
Mm-hmm. Yeah, our ultimate goal on a tune-up is to leave it running better than when we found it. That's our ultimate goal on a tune-up.
And the thing with the recommendations, when we're educating and we're giving recommendations, that's what they are. They're good advice. You don't always, it may be running like you say, and we found a part that's worn and would benefit the air conditioner to replace it. That doesn't mean you have to. You can wait till it breaks all the way if you want to. We're trying to help you avoid some of those inconveniences of being broke down.
I think that's a good point. Typically, if you're doing a tune-up, it's because it is running, right? You don't call for a tune-up typically on something that's already broken and not functioning at all. And so it's going to be something that's running, and that's why it's important to go through and check all that stuff.
What do you say to, or how do you help a technician know how to communicate the recommendations to a customer in a way that is transparent and honest? Because I feel like as a technician, there's got to be a little bit of fear and anxiety to like go into a system that you can see was installed improperly. The customer knows it should not be at the end of its life, but because it was installed wrong or the maintenance was neglected or for whatever reason, all of a sudden they've got a page of recommendations, and there's like this anxiety on the technician's part of like, crap, this customer is going to think that I am trying to like take advantage of them. How do you coach a technician through that to be able to have the courage to like actually go through and present that? Because that is a fearful moment, because I don't want anyone calling me a liar or saying that I'm trying to scam people.
Well, speaking from experience, because I've been in that exact scenario right there lots of times. And, you get to that point and you go in there with this big long list, and knowing that there's probably somewhere in the background of the customer's mind a thought that, I hope this guy's not here to take advantage of me. And you go in with every good intention, and it's intimidating, But I think that as a technician, the best thing to be is honest, show your expertise, right? And make sure you take the approach of, look, I'm just here to instruct you. I'm just here to teach you about your unit, right? And if you go with that mindset, and I always took the stance of, regardless of what you do, Mr. and Mrs. Homeowner, this is your decision, right? And for me, it doesn't matter either direction. If people want to leave it with a worn out part in there, that is 100% up to them. And, if that's the way they want to go, even though I wouldn't recommend it at the time, that's fine. They're 100% entitled to make the decision and do whatever it is that they're going to do with it. And I think if you can take yourself out of it and take that approach, it makes it a little bit easier to go and talk to people. And I think they can feel that honesty and the fact that you're just there to help. They can tell if that's your intention, I think, if you can take that angle.
Richard, you manage the tune-up and service technicians. What do you train as far as like the communication that they should be having with the homeowner to communicate that so that they don't come across as pushy or just trying to make a buck?
We like having the homeowner with us when we do the tune-up. That way, when we're doing the testing and we're going through and evaluating everything, we're pulling out the manual and making sure, and the manual is really the one that's going to tell us where it should be or where it should not be. And it's not my technician making that call. So we like having the homeowner with us and kind of just going through the whole journey itself together, so that, you know, my technician can educate at the same time. It's like, hey, let me kind of talk to you about how this works. And same thing with the, you know, my technician may have some question. My homeowner's like, you know, how's this work like this or whatever. But ultimately, we like to have the homeowner there, and then they test things together.
Okay. But if the homeowner's not there, what's their procedure?
So basically, they'll make the list here. They'll go through the tune-up sheet. They'll document everything. And then they'll sit down with the homeowner and do the same thing, kind of like they're retesting it, and say, hey, here's this part. Here's how I tested it. Here's where it's at. Here's what the manual says. And just kind of go off that, so kind of educate the homeowner what it should be and what the manufacturer says. That answer your question?
No, it did. I'm always trying to like figure out. I don't know at what point and what events happened that give the industry a bad rep.
Well, I have my opinion on that.
Share it. Just
Kevin's over there laughing.
Keep it clean.
No, my opinion is everyone wants to be the hero, and they're okay to, you know, bash on somebody, and that's not what we want to do. Like, hey, you know, here's what the recommendation is. Take it or leave it. But we're not out there to throw anybody under the bus. Or I think there's so much.
Who's bashing on who in this scenario?
We get a lot
contractors.
Contractors. Like, I have a different opinion. That guy's wrong, and we get this all the time. Unfortunately, it's like, well, I had this guy say this, and you're saying this. Like, who do I believe? It's like, yeah, you're kind of tough. Like, all I can tell you is here's what the manual says. Like, what does it tell you? So we like to have the customer be educated enough to make those decisions.
So it's hard, and just wanted to give one example, right? I was out, I did a tune-up, found a capacitor that was on the air conditioner, and it was down. They've got a percentage range, right? And it was actually down about 30%, right? It was pretty significant. It says it right on the side of the capacitor. Most capacitors they need to be within 6% of what the amount is that it has listed on there, right? And here I was down 30%. Well, customer, they wanted to have a second opinion, look at it. Actually, if I remember right, it was a home warranty. He had his home warranty company come out. They sent a guy out to look at it.
Before you or after you?
After I did, right? Because, you know, he didn't want to have to, which makes sense. You know what? If you've got a home warranty, have them come out and they'll cover the cost of repair. It's a great way to go, you know. In this case, the technician came out, tested it supposedly, and said, this is fine. Don't know what the problem is, because your unit will still function with your capacitor being down 30%. It'll still kick on, it'll still run, but it's not running properly. And it says it right there, you know, that it's got to be within that certain range. Now, he's telling the customer that, no, this is fine. That guy's trying to take advantage of you, right? And I ended up back out at that customer's house, and I had to do exactly what Richard's saying. And it was one of these scenarios where the customer wasn't able to be with me. And so, but when I was able to get the customer with me and go through everything and explain, you know, the different manufacturer recommendations with it and everything else, well, at that point it was, oh, okay. But so the issue is you get somebody to come out, like Richard says, wants to be the hero or whatever else. Oh, no, you're fine. In this case, I actually think it was a home warranty issue, and a lot of times they'll just want to not cover things if they can. Can I say that?
That's the way that it is.
Yeah, I mean
their business model is to have you pay a premium, and then or a deductible. I don't know what the thing.
If they can avoid paying for it,
correct.
That's where they make their money, is by not having to fix stuff if they can avoid it.
It's funny you say that, Kevin. I am dealing with a situation exactly like that right now. I had to go back out on a house, on a capacitor, on a furnace, and I was going through the homeowner. And, hey, you know, he's like, you guys are this, that. So I'm like, okay, well, let's pull it out and test it. So I pulled it out and tested it, and he's like, oh, what are you doing? I'm like, well, we got to test it. He's like, oh, the other guy didn't do that. I'm like, wait, my guy? He says, no, the second opinion. I'm like, well, how's he going to tell if it's wrong? Yeah, so we pulled it out and showed him the labels and everything. He's like, oh, wow. So he was pretty upset about the other guys.
So it gets frustrating as a technician when you're out there, when you run into this kind of stuff, because, you know, the homeowner's getting information from everywhere. So I think the main thing that you do is you just stay with what you know. Right? This is all stuff people can look up if they want to take the time, right? But stay with what you know and be honest and make sure you're on the customer's side.
You know, as frustrating as you say it is for technicians to like have that happen, I would think it's got to be amplified even more frustrating for the homeowner, because they've had to take the time now to have 2 or 3 different people out and to get different conflicting opinions. It's one of the things that's most annoying to me is that we cannot tell the difference as technicians between opinion and fact, and we try and pass off our opinion as fact.
Yeah, what we can do, and we have done in the past, is we have someone that's not available to be there, or like an older couple who can't get downstairs. We'll actually take a video of it. Hey, here's me testing this thing here at your house, Mr. and Mrs. Jones, whatever, and then take it upstairs and show them that, and do the same thing with anyone that can't be home at the same time. It's like, we can send you that video so you can see what we're actually testing in your home.
Yeah, it's nice now with technology what you can do as far as that goes.
Really, it ultimately comes down to trust, because you're going to, which technician do you trust as the homeowner? And when you are faced with having to spend, being told that like, hey, you got to spend $150 to replace this part, and the next guy comes out and says, no, you don't, like, oh, well, I like the guy that says I don't have to spend money.
Yeah, exactly.
Right? Because there's already this perception. And so it's a challenge. And I don't know that the technicians always fully appreciate that one of the things that they're out there to do is to like prove themselves worthy to earn the trust of that homeowner. And our service system and everything that we go through and documenting and trying to make things systematic are there and designed to try and help the technician be set up for success, to be able to communicate properly to the customer and earn their trust, so that they know that like this stuff isn't meant to be opinion. Like Richard was saying, there's a manual that we go through and do this stuff. It's just, if somebody came out and let's say it was like a really big repair, or let's say my car, and I take it into the mechanic and they're like, hey, you're going to have to pay $7,000 to put a new engine in, or $3,300 to get a new transmission. The part of me is going to be like, I think I'm going to get a second opinion.
Did your kid forget to put oil in it?
No, but I just my oldest just turned 16 and started driving.
I was tempted to say
I'll have
one.
to replace an engine soon, I guess.
I was tempted to say one of the kids in the family, but I had to.
Your brother is sitting
right
right next to you. He'd be like, I know which brother that was.
And it was not this one.
No, Mike, I was just looking up on, for example, we have 8,588 reviews. We're a 4.8 star company. Go with your gut. If you have some questions, like by all means, call in, ask for me. Like over the service and tune-up guys. If you want some more clarification, I'm happy to answer any questions over the phone, or if you want us to come back out, we're happy to go back out.
I think that's important, like you're saying. Find a reputable company. If it's us or someone else, you know what I mean? Just make sure they're reputable. They're someone that has the reputation of coming in and doing and making sure they know what's what. This is one of the things that just drives me crazy about the industry, is the undercutting and backstabbing. And the lack of education also. You get a lot of people who they'll jump into this trade, right? And their route of training and education may not necessarily be in service, right? There's a few different aspects with new construction and installing different things and whatever else. And they'll call someone out like this, and honestly, there are a lot of times they have no idea what they're even looking at or talking about. And they're giving recommendations based on that. You need to make sure you've got someone out there who is trained and knows what it is they're looking at, knows what the manufacturer specs are, and can actually test for them, has the tools to test for them. And that's huge.
I can understand why customers are stressed out by this, though. There is a lot of stuff in this equipment, and there's a lot of ways, if an individual was dishonest, they could take advantage of the customer. It does happen out there. It's not going to happen here, but it does happen out there. And that's why, like Richard said, we're going to bring you along the journey with us. We're going to hopefully have you stand beside us while we test this equipment. We'll show you the numbers on the side of the capacitor, and we'll show you with our voltmeter that it's out of specifications if it is. And so, yeah, it's scary. I see why they're scared and why they're nervous to bring people in. It doesn't have to be scary. We can make it comfortable.
And there's nothing wrong with questioning whoever's out at your home. Ask them why. I'm a curious guy, period, anyway. And if my air conditioner was working and I thought like, hey, I'm just going to have this, tune-up done, $100, knock that out, and like get the annual maintenance done, and then they come back with, a couple $100 of repairs, I'm going to sit there and be like, okay, help me understand why this thing is running, but you're saying that it's not running right, and let them explain. And hopefully the technician doesn't get frustrated and has the communication skills to be able to communicate those things, because that's, people don't realize that, like, in addition to the technical knowledge, that communication is really important as well.
We like questions. Like, that's one thing we go over quite a bit, is we like customer engagement and asking questions, because our goal is to educate you, and so you're understanding this, so you don't have to take, well, he says, she says, that thing. It's, hey, I understand this. I can make a decision for myself. So that's what we like.
One of the big things too is technician needs to go in there and understand that customer, they don't know this stuff. That's why we're out there. They don't know. And so they should expect a customer to have questions. They should expect to and be ready to answer those questions competently.
All right. Any technician out there listening, expect questions. Don't get frustrated. And the answer should never be, because I said so. It's also, I think there's a fear that people think that when someone comes out there, if they've got an older system, that the technician's going to say, well, you need to replace this thing. And sometimes that might be a recommendation, but I always tell people that if a technician comes in after spending time with your system, and the first thing and the only recommendation that he has is, you really should replace this thing, like, get somebody else to come out and talk to you, because unless they don't make parts for your system anymore, and if your system is that old, like, you might have a different issue, but unless they don't make parts for your system anymore, you should be able to repair most things on the system. Now, everything costs different things, and after you see the bill, you may think, like, okay, well, instead of putting, $800 or $1,200 towards, replacing a motor or a compressor or, all of this other stuff, you might think, oh, well, I'd be money ahead to get the thing replaced. But again, that technician should be out there, unbiased, present the information, because that technician knows nothing about your financial situation. What if you still wanted to spend $1,200 to repair the thing? And even hypothetical, a stupid hypothetical, but let's say that it was $2,100 to replace the thing, and you're being offered $1,200 in repairs. A technician may not even present the option to repair the thing, but not know that you don't have $2,100 to do the thing, and maybe you can't qualify for financing. Maybe you've only got $1,200 and you want to repair the thing. That's not the technician's job to sit there and judge you. Their job is to be out there, present you with information, and do whatever you want them to do, and do it with a good attitude.
Oh yeah,
or get the heck out of my house.
I'll do whatever if they want.
Customer service pisses me off.
I feel weird right now. I feel like Mike's angry at me because he's staring across the table.
Well, you're the one. I don't have to move my head a lot. Like, look.
I'm like, I'm sorry, Mike.
I get fired up about customer service.
No, you're right though. Like, if you got an old system, you want to fix it, I'll fix it. If you want to replace it, my goal is ultimately to make sure you have a reliable system that's going to last you. It's not breaking down Friday night. I'm going to tell you, if you got an old system, hey, you might want to look into getting a replacement. However, I can fix it, whatever you want. But yeah, you're right, Mike. I'm on board with you.
Go ahead.
I was just going to say, one thing to keep in mind also as a customer is that this is all based off of recommendations. There's no fortune telling in this. There's no crystal balls. And so one question that I remember getting a lot is, well, how long is this going to last me? And people want to know, okay, well, if I don't do anything right now, can I get 3 months? Maybe. Shoot, you might get another year or two. The thing of it is there's no crystal ball. So what we're doing is giving recommendations based on the facts and information we have on the equipment at that moment.
I just ordered a crystal ball. I'm going to return that. Yeah, it said guaranteed to work.
Yeah, it will. It's crystal. Paperweight. Hold that paper down.
So, well, let's actually dive into the tune-up sheet and talk about the kinds of things that are included or should be checked when you're going through a system. So on the sheet, it starts out, and we talk about just really basic, starting up and running the unit. Why is that the first thing that we're doing?
Well, it's like I was saying before, a tune-up is for a unit that will turn on. And so if I show up to do a tune-up and I go to turn it on and it doesn't turn on, well, there's something else going on, something that needs to be diagnosed out. And a lot of people, people are I think, famous for this with their cars too. Oh, it's making a noise. I'll just get a tune-up and maybe that'll fix it. And I think a lot of people do that also with their air conditioners. I'll just see if I can get a tune-up and maybe, in the course of the tune-up, it'll get fixed. If it's not coming on, then you need something a little more than a tune-up.
Yeah, and I mean, there's a protocol, there's a procedure. It's different procedure to troubleshoot than there is to go through the tune-up.
Without it running, most of what's on our list, you can't even get in there and check. So.
And that's why that's first on the list is if we go to a customer's house and we try to start the air conditioner, it just doesn't turn on. It's a whole different situation. And now our recommendation is, well, let's get this thing started. It's going to need this first so we can do a diagnostic. We can do the repair and then continue with the tune-up.
So after that thermostat, what types of things are we looking at the thermostat, or what are we looking for at the thermostat?
Batteries, level, just for looks on most of the time there. Is it secured to the wall?
Make sure that it's actually turning on the right thing at the right time.
Okay.
Make sure the date and time are correct.
Honestly, when I'm there, I'll just, if it's a programmable thermostat, I'll verify with the customer, hey, do you like the way that your thing is programmed? Do you need help? A lot of people don't realize that they can program or just get frustrated at some point and don't want to mess with them. And whether you do it right then or later on, you want to let them think about it. It's something that you can help people do while you're out there.
Interesting. It says, and I'll let you guys talk about it, but we're out doing an air conditioner tune-up, and we're going to check the furnace fan motor and wheel alignment. Why are you checking the furnace while you're out there, messing with the air conditioner?
Well, that air goes through the furnace. It uses the same blower motor.
Yeah, a lot of people don't realize that, there's shared components between those. But what are you looking for there, and why?
Making sure the squirrel cage is clean.
What's a squirrel cage?
The blower wheel.
Yeah, blower wheel. You know what like a squirrel cage, the little run on a squirrel runs on it?
You mean a hamster wheel?
Hamster wheel, okay. We call it a squirrel cage. But hamster wheel, okay, different word. But it looks like that. And
Okay.
if it get dirt and debris build up on there.
I've never seen anyone have pet squirrels and exercise them on. Like, when I think of a squirrel cage, I think of squirrels are annoying. I'm going to trap them.
In 20 years, I
Cage
don't know
them.
I've ever heard anyone call it a hamster wheel.
I'm not saying you called it a squirrel cage, but you described it as a hamster
Yes,
wheel. That's
you're right.
all I'm
No,
saying.
you're right.
Where's
It's-
Mike from again? Maybe we should
there's
call
a
it
term.
a possum wheel.
Awesome.
You also do not put possums in a wheel to exercise them that way.
You don't know.
I do know. I'm from there.
We just called it squirrel
Mike's
cage.
from Possum Town.
But, this is a good point. Like, squirrel cage does not compute to the average homeowner. And so just being aware of those types of things. So I know what you're talking about when you say that. I'm just trying to point out how stupid it sounds. I'm just kidding, kind of. So
Let's see. We're going to go ahead and change this up here.
no. Okay, so what? Sorry, I interrupted. But
No,
what
no.
are you checking for when you're looking at that?
Well, you do bring a
fan
good point.
motor?
If squirrel cage, if that's not something a homeowner associates with, I'm gonna have to ask around some of my guys and find out if they're using hamster wheel, because now I'm just curious. But
Well, I don't understand why you can't just call it the
lower wheel.
Yeah, the
fan
blower wheel.
assembly.
I think
the,
it's just
the fan blades.
something I've said for so long, I'm just stuck on that.
No, I get that. And as a homeowner, here I just want to throw this out there. As a homeowner, you do not want to come across as if you don't know as much as that technician, because that can come across as weakness, and you want to have a position of authority. Especially, my wife tells me all the time that she feels like when technicians come into the home, not our technicians, she actually draws the comparison and say that ours are better. But when we've had other technicians for other services come out to the home, when they talk to her, they come across as condescending. That like, oh, you don't know what I'm talking about. It's the squirrel cage. Like, don't worry about it. Trust. And so she goes to the point where she just doesn't even ask questions. She doesn't contradict. She doesn't let anyone know that she doesn't know what's going on, because she thinks nodding and pretending like she's understanding what's going on is going to not throw any red flags to the technician. But in her head, she's like, this guy's gone. I got to call Mike and ask, what's this guy talking about? And so just be aware of the terminology that we're using talking to a customer. Just because it's an industry term doesn't mean that it's a homeowner facing term.
No, you're right. Like on this step here, inspect furnace, fan motor, and wheel alignment, we'll actually have it outside so we can adjust that point. That's where it's like, hey, this is again, we may call it that, but they'll at
Sure.
that point see a visual of it at least.
Sure. Okay. So sorry, I keep like distracting us, but like, what are you looking for there, and why? Like, why is that alignment an issue?
If it's not aligned properly, or if it's not clean, you get dirt buildup on there, it's not going to move the air as like it should, and that can cause some problems with your refrigerant levels.
If it's out of whack too, we're talking about alignment. If it's not balanced, let's say, and that thing spins. If it wobbles, those things spin super fast. And if they do that over an extended period of time, that wobble can get worse and worse and worse. And eventually, I've seen squirrel cages, hamster wheels, and blower wheels, right? I have seen them completely disintegrate, right? Because they were misaligned. They had a wobble and it just was allowed to go, and they got worse and worse and worse. I saw one time that looked like it had exploded, and it sent fan fins. One of them had actually punctured the housing below it. And from the wobble, you could see where the housing had actually torn, right, about 2 or 3 inches, and it had bent the shaft on the blower motor. So had that been caught beforehand, you're talking right now, I've got, if it's just replaced the blower wheel, as opposed to replace the blower wheel, the housing, and the blower motor, you can see how the expense would add up, right?
Yeah, and I think people don't realize that if part of their thing that they're doing is if they look at that blower wheel, because if you remove the cabinet, you can usually look at it. And you talked about dirt being built up on it. I don't think you realize how much that affects the amount of air that it's actually moving, because those fins are designed to be spaced a certain amount apart, to be rotating at a certain revolution.
The angle of the fan blade, everything, yeah.
Yeah, all of that stuff is specifically designed that way. And if your filter's dirty, or all of those things that are designed to keep dirt off of those from building up. Actually, if you've ever noticed dirt building up on your ceiling fan, like on the leading edge of your ceiling fan,
it's true.
More than likely, you've got that same buildup happening on your blower fan down in the furnace, because that is a indication that there is stuff in the air that is, when it impacts, it just kind of sticks and stays on there. Anyway, okay, so after that, you talk about checking the fan motor for buildup. We talked about that. Capacitor MFD for allowed drop. What does that mean, and what is that you're checking?
So this is what I was talking about earlier when I was talking about the capacitor on the air conditioner, right? So the different motors in the unit typically have a capacitor. Dustin's pulling one right there. If you're watching the actual video, this is a dual run capacitor that would go into an air conditioning condenser, right? Basically, you're measuring microfarads, right? And in fact, if you look at this one, where does it say it?
On the label.
You have a defective one.
I actually found that in the dumpster, and I just wanted a prop for my table.
So right there.
It looked fancy.
Right there. I was looking for the plus or minus, and
Got it.
I don't know. It says right there, plus or minus 5%. It's giving me, so on this one will actually run a compressor and a fan. That's why it's called dual, right? Because it's doing 2 motors at the same time. The one that's in the furnace is only going to do the blower motor typically, right? So this one is stating plus or minus 5%. So I've got 5% that I can allow this to drop before I need to start thinking about, hey, this is out of spec and I probably should be thinking about replacing it. So when it says 45, if I look at that 45, that's talking for the condenser itself, or the compressor itself. Richard, what's 5% off of 45?
45 minus
2 1/4.
42.75.
So if I get in this and I measure below 42.75, manufacturer recommendation is that gets replaced, right? And so that's the kind of thing that we're looking at when we actually get in to look at these capacitors. Now, this thing, if it's left to keep dropping, whatever else, I've seen these things get to the point where they completely rupture, or they just, more often than not, they'll just stop working.
They overheat. They start to swell.
Oh yeah,
yeah. So you were going to say something.
Yeah, I was going to say, in more answer to your question, we're looking at this tune-up sheet. This is kind of technical. We're talking about not being too technical with the customer. Microfarads, MFDs, capacitors, those are technical things, but we're there to educate. So when you're standing there with our technician, we'll take that capacitor, show you what it is, show you the reading of the microfarads, test it with our voltmeter, show you what the actual reading is, and show you that it's below the percentage drop if it is. Does that make sense? So it is kind of technical on the form, but we're there to educate that.
Yeah, we're there as a translator of this. This form is like the Egyptian hieroglyphics, and we're the interpreter that actually tells you what it means. But tell me this: what is a capacitor, and what is its function? Why is it important? Why are we checking it?
Helps it start.
How?
The easiest way to explain it is kind of like it's a battery.
Okay.
You ever had to jump start a car?
Yep.
It's kind of the same thing. It jump starts a motor.
Okay.
If you look, most motors, they work with magnetism, right? Mm-hmm. And so they've got, like any other magnet, a north and a south. And so the tendency is that it's going to want to stick, right? And so you give it basically the capacitor gives it a oomph, an extra kick, right, to just get it going. For a start capacitor. Yes.
It's a technical
term. Patent pending.
Okay, so it's there to give it an extra jolt, to give it extra juice, so that it is an extra oomph. And it's there to take stress off of the motor itself, so
Correct.
that it's absorbing that extra oomph, that extra jolt there, and it's preserving the life of the whatever it's helping to kickstart, whether it's the compressor or the motor. Is that right?
Yeah, you're right. Dustin when he was talking earlier, he had one that was 30% low. It may still be starting it, but you're adding extra wear and tear on that motor by having this below that 5%.
And that's the thing, is that the thing still might be cranking up, but it is shortening the life of the motor and things like that. That's why the thing is put there, so that you can replace this capacitor that's less expensive more often than you're having to replace the motor that's like really expensive. Is that a more common part that goes out?
Yeah, you see those all summer long.
Yeah, the hotter they get, the more they go out.
Mm-hmm. Is that, I'm thinking of like how long should that last? If a customer is having to replace one of those every year, is that too often?
Oh yeah.
If they're having to replace it every 4 years, is that more reasonable? Or is it 5 years, 6 years, 7 years? Like how often? We see them all the time, but we're out looking at hundreds and thousands of air conditioners. But like a customer, are they going to replace that once in the lifetime of the air conditioner?
Well, let me tell you, my house, I've been in my house for 14 years.
Yes.
I had a brand new air conditioner when it started, right, when I got in there. And I had to replace it 3 years ago. And that's the only time I've had to replace it so far. This is one of those parts when you look at the manufacturer warranty. So you got a 10-year manufacturer warranty, and it goes out at 10 and a half years. Right? You got a whole bunch of little parts like that. They can go out at any time, and there's no standard, it's going to go out at this time or this time or this time. But I would be willing to say if you were replacing it more often than once every 4 or 5 years, there's probably something with your install that's not good, or things are dirty and they're just not able to run properly. You know what I mean?
Okay. Let's see. Measure blower motor amp draw. Why are you measuring? Actually, and the capacitor in this particular checklist that we're checking, there's one outside and then there's one inside at the furnace for the blower wheel. And so, okay, so checking the measure blower motor amp draw. Why are you measuring that? And what is that a sign of if it's out of whack?
Dustin looks like he was about to say something.
No, go ahead. I'm reaching for my drink.
It's kind of like telling you how hard it's working. So if it's higher than it should be, it's working harder. You could have dirt built up on the hamster wheel or the blower wheel or the possum wheel, whatever you want to call it. But
never called it a possum wheel.
We've started a new trend.
If you were in the South, maybe you could call it that, but that's still not a thing.
It tells you a lot of different things. If you got a high amp draw,
if it was a possum on the porch, like if that was something you could relate, like because we'd have possums come on the porch and eat cat food all the time, but never got in the hamster wheel. Okay, sorry, what were you saying?
I was thinking of a comeback. I have one. If it's got high amp draw, then it's just not it's working harder than it should. Mm-hmm. It's drawing too many amps, and there's a problem somewhere.
Is that fixed by, because you said there could be dirt building up, is that fixed by cleaning, or if it's drawing too many amps, is that something where it's like, okay, we're going to have to end up replacing this motor sometime?
It could be one, it could be both.
Okay.
Could be
It could be that it got to that point that it needs to be replaced because of the lesser, just because I considered cleaning stuff up, that's a lesser issue, right?
Yeah, it could be a dirty filter. It could be a lot of different things. When you get all those things, everything checked out, then eliminate it down to just the blower blower motor, sorry, then it's the motor.
Okay. Checking the ductwork for obvious air leaks. Tell me about that.
Well, you don't want to be losing air where you shouldn't be losing air. You don't want to be blowing hot air in a crawl space or an attic or cold. You want to make sure that you're getting, all the air directed where it should be going.
This is another area where we can just offer good advice, good counsel to the people we visit with. It's not always about just the equipment operation. It's about making your home more energy efficient while we're there. So it's a simple observation we can make and make recommendations on.
Well, and also people don't realize that the air blowing through the ductwork, that is part of the function of the system.
True. Mm-hmm.
And so whether you are impeding that by shutting off registers or you are impeding it functioning because the air is leaking out other places. I mean, one of the things that they might be experiencing is like, hey, it's not getting conditioned in this room, and we're doing our inspection, and all of a sudden there's a hole or a gap or something in that particular line that's going to that room or something that could be causing it. What you're doing is you're losing pressure and causing all of the rooms to not be conditioned the way that they could.
Yeah. It's making, you figure it's pushing air, and if it's not pushing the air to the right place, well, obviously that place is not going to get conditioned the way that it's supposed to.
So checking the next thing, check line set, installation, condition. What are you looking for and why?
Making sure it's not cut. We talked about it a little bit on last week's episode or the previous episode, how you don't want those cut because it can condensate and have water dripping and causing.
So you're talking specifically about the insulation around it.
Mm-hmm.
So is that all you're checking, is making sure that the insulation is intact, or are there other things you're checking?
No, we're just checking that.
Okay.
Well, and also it tries to maintain temperature, so it does function more than just water dripping. It does the function of the air conditioner.
Got it. Oh, I said check line set insulation, installation, but it actually says insulation. That's why you're saying that's what you check. Okay,
that's why. Okay.
As soon as you said that, I looked at it. I'm like, do we have a typo here?
No, Mike can't read. That is well known.
But you do so good.
Nope. Okay. Inspect evaporator coil for, and if I say something wrong, don't just go with it. Correct me. But
we'd be correcting you all the time, Mike. I'm sorry. We don't have that kind of time.
Okay. Let's see. Inspect evaporator coil for blockages, if possible. So tell me why that's important. What is the evaporator coil?
Evaporator coil is essentially, it sits above your furnace or air handler, and it is where you've got the refrigerant running through those lines. It's the part that gets cold, right? That the air blows across to be able to cool that air down. So the issue is if you can't blow air through it, then you got a problem. You're not going to be able to cool down that air. You're not going to be able to get it to the parts of the house, and you essentially make it so the thing's not going to work because those coils will actually get too cold, and the natural condensation that we get when we're running an air conditioner will start to actually freeze up, turn that into a block of ice, and then it poses a whole bunch of other problems with your condenser if it's running like that.
We talked about the coils on the outside unit and how you could spray them off with a water hose. The coil inside, it looks very similar. It looks like a radiator coil, and as the air is blowing across it, if your filter's not sized properly or if it's dirty and things are getting by, you can get animal hair, dirt, dust, and things that build up on that.
I think it's important to understand too. So anytime, I'm going to sound like an idiot when I say this. For every action, there's an equal and opposite. Okay, yeah, good.
Newton's law?
Yeah, exactly. I told you I was going to sound like an idiot.
That's all right. I couldn't spell Newton's law, but I know what it is.
Excellent. So if I'm making cold air making cold in one spot,
yes,
I have to make, according to that, heat in another spot, right? And so that's essentially what's happening between your evaporator coil and your condensing coil. You're taking the heat and putting it outside and putting the cold and putting it inside to dumb it down, right? And so both of those need the airflow. Both of them have to have the airflow. And so if it's getting plugged off, it doesn't matter if it's good outside. If this is getting plugged off, this whole system's not going to work right.
Got it. So next on the list, we've got flush condensate, drain, and check for blockages. We've talked about that before. The importance of your evaporative coil is creating moisture, and you got to make sure that that's got somewhere to go so that it doesn't overflow onto the other components. So you want to make sure that's clear. External, yes, Dustin.
I got to point out one thing on that. People think that it just drips a little teeny bit of water. They don't realize it's a significant amount of water. It'll produce a gallon an hour. I remember there's always a story.
Tell it.
At one point in my life, it was a weekend, and I couldn't get to the store to fix my own air conditioner, and I wanted it to run. What had broken down was the condensation pump. And so I put a 5-gallon bucket underneath that, thinking that'd be enough to catch all the water overnight so I can sleep cool. So I put the bucket on there. By the next day, there had to have been 5 gallons in the bucket and 5 gallons on the floor, because it produces a lot of water just from the condensation in your air conditioner.
There you go. When you're checking that that drain line, is that when you also check the operation? Nope, I see it as a separate thing here. Testing the condensate pump for operation. That's so if you do not have a floor drain that it's going into, or a 5-gallon bucket as Dustin had, they usually run it into a condensate pump, and that pumps it out, and making sure that that's working. Is that the thing that went out? Was your pump went out?
Correct.
Got it.
One thing to point out, so I deal with installs a lot, and when we go in, typically we're going to replace that condensate drain as it comes off. And I remember I did an object lesson with my guys based off of one of those that came in, just to show them how important it is to make sure that we replace that condensate line when we're doing a brand new install. And we had 10 feet of 3/4 inch PVC that was 98% of the way blocked off. I mean, water wasn't getting through it. It was actually backing up and spilling into the condenser, or sorry, spilling into the furnace, right? And so build-up, it can have this stuff build up over time, and so that's why this is something that we check, because the last thing you want is to have that water spilling over, ruining your furnace, flooding your basement, you know.
Another thing, external static pressure. What is it? What is static pressure, and why are you checking it?
It's to check your airflow, kind of checking how hard your blower's working as far as moving air. You don't want it too high, or it means you're not moving the air that you should be. Here in Utah, with our altitude, we already struggle with that, so we want to make sure that that's not where it shouldn't be. If it's too high, it's going to cause some problems on the system.
So is the static pressure, is that a reading that what it should be? Is that coming off of the blower motor, like it should be moving a certain amount, or is that static pressure based off of the ducting size? Like, where do you get the reading that says, hey, this should be different?
In the ductwork.
In the ductwork.
Yeah, we get in the ductwork, and the manuals tell us where it should be.
Got it.
So it's not going to be this is what his opinion is or anything. It's going to be right on there, and a lot of times it's on the actual nameplate.
This is where you run into duct sizing issues, though, because if your ductwork's too small for the equipment that you've got in there, you're going to end up having higher static pressure, you know. And then some of the other things, you know, filters, whatever else that's dirty, I mean, those are going to cause your stuff to be higher. And typically, if you're running with a higher static pressure, that motor is working harder than it should be. And so something to ask yourself, if you're having to replace a blower motor every other year, you know, there's a good chance that you've got an issue with your static pressure, right? Issues with your ductwork, or issues somewhere.
So if the static pressure is higher, does that mean that it's moving more air, or it's moving less?
Moving less.
Okay, so the higher the static pressure, the less air it's going to be moving. So really, that measurement is checking to see if it is moving the air at the right quantity, the right velocity.
Yeah, we get and that's a separate thing there. Velocity and static is different, but you get a lot of questions. People say, "Hey, I just need a bigger air conditioner." Then we'll check the static pressure. Like, no, we need to lower your static. That'll your air conditioner size properly, you know, and some repairs. And they're like, "No, I just need a bigger system." Like, if I put a bigger system in here, it's actually going to be worse because my static's even going to be higher now. So that's something we have to watch for.
You point that out, Richard. I've seen multiple times where we've given that counsel, and so they still want a bigger air conditioner, so they go to somebody else, and somebody else will actually sell them a bigger air conditioner and do them that disservice, and then they're calling us back later saying, hey, I didn't listen to you. I bought a bigger air conditioner. Now I've got even bigger problems, and those solutions can oftentimes be really expensive.
It's not fun to have to buy 2 brand new air conditioners in consecutive years.
Yeah.
Okay, the next thing you're checking is the temperature difference across the evaporator coil. What are you looking for? Why are you checking that?
We're looking for a temperature difference between 18 and 22 degrees.
Why?
Just to make sure it's cooling properly. If it's lower than that, it's not doing, the air conditioner isn't working 100%.
It's indicatory of other things and functions in the system, right? It can point you in directions. If you're having issues with that, tip you off and let you go start looking for other issues that might be there.
So when you're checking across, are you checking there at the return and then putting a probe up above the evaporator coil? Because that's when the air should be the coldest, right?
Typically, yeah.
So you're looking for an 18 to 22 degree difference, or you're looking for 18 to 22 degrees
Difference.
because that would be cold. All right.
Yeah, if it's blowing in, if it's coming in 85 degree air, then up above it coming out, you should have 65 degree air coming out.
Okay.
Basically.
Yeah. Filter system. When you're checking that, what are you looking for? What are you seeing out there?
Making sure that there's no gaps around the filter. Honestly, we go out to a lot of them and people have put just whatever size they could find filter in a filter rack and maybe it doesn't fit right. And so you look in there and there's, 3-inch gap over here of air is able to get around it, and it's not making it. Also, I'll look at ease of how hard is it to put this filter in for these people. A lot of times people don't replace a filter or don't know where the filter is because it's just in a difficult place to get to.
Do you remember when we first got into the industry? So this is 20 years ago. Kevin and I both got into this industry together, and we were still living at home. We're thinking, hey, this will be cool. Let's help mom and dad out, fix their equipment. So we ended up going in to work on their equipment. We said, hey, Dad, where's your filter on this one? He had 2 furnaces, one for the basement, one for the main level. And he's like, well, I don't know. And so we finally found it, but he'd had this furnace there for 20 years and never changed the filter because he just didn't know where it was.
Did you ever wonder why the air conditioner went out?
Yeah.
Well, it had nothing to do with grasshoppers.
So anyway, it had gotten so plugged that it had just folded over and just collapsed. And with the filter, yeah, and it just was doing no good, obviously. So we were able to take good care of them at that time. But yeah, filters are important.
Well, and so I want to point this out too. My dad, he is a handy guy, right? He was actually a builder for a lot of years, and he's the guy that knows how to do everything, from plumbing, electrical. I mean, I've seen him do amazing amounts of stuff. And the fact that he was unaware of the filter in his own house, it was kind of surprising. But you got to take that as a lesson with everyone else out there. Right? There is a lot of people out there who don't even know where their filter is.
Well, their furnace is in a closet. It's out of sight, out of mind. You're not thinking about your filter.
Oh, yeah.
So that's the stuff that we check inside. As we're moving outside, the outdoor disconnect, what are you looking for? Well, actually, I have a question. You've got outdoor disconnect, and then you've got blades, breaker, fuse. Tell me what blades, breaker, fuse, and what you're looking for out there at the disconnect.
Well, we're looking at the style. Those are different styles. So blade breaker is kind of just that makes a connection. I'm not a big fan of the blade connectors just because they can tend to have a little more arcing and welding.
Is that the one where you pull out the
that's
thing
the
that's
one.
a blade?
And if it's welded, you rip the whole disconnect off the house. I've done that a couple times.
Yep. You pull all the guts out.
Yeah.
It's like, ugh.
I'm not a big fan of the blade.
And typically if that's happened, because it's welded, there's been some heat in there. So like the plastic components inside have melted a bit and things are brittle, so they just fall apart.
Yeah. So we're looking for that. We want to make sure, and that's just documented so we usually homeowner know what kind of a system, everything you have. Breakers, just your average breaker. You got one right here. You click it on and off, just like that. And then the fuse disconnect, it has a fuse in there. There's certain application that's for code they're required.
Okay, so you're just checking the condition of everything there to make sure that it's functioning properly. The AC electrical breaker size, that's if you have a breaker, you're documenting what size. Are you verifying? Do you ever come across like improper sizing that doesn't like match?
All the time.
Why would someone do that?
Because they had the breaker on the truck and they were like not wanting to go to the store to get a different one. They stick it in.
Really?
Oh, yeah, as easy as that. I mean, I wasn't there when they did it, so maybe it was a different scenario, just saying. But, yeah, I mean, maybe some people, now, contrary to common belief in the HVAC world, HVAC technicians are not typically licensed electricians, right? In fact, I remember when we got into this, like you were saying, seeing some really sketchy, scary stuff on some installs. And even today, we go back on some jobs where we're like, holy cow, did you see how they pulled that power, or where they hooked that in at, or the breaker that they did on there? And so you end up with a lot of stuff. Some of the issues you get are they've double tapped in. In other words, there's been an existing breaker, and the wire that was ran to the air conditioner, they've actually stuck it under that same breaker, which creates its own set of problems. Or they're using the wrong kind of breaker that just conveniently fits in that panel, but it's not listed to be able to be used in that panel, right? And then you've also got the size to boot, which if it's not sized right, that creates a bunch of issues. I mean, if you've got a AC and it's supposed to have a 30 amp breaker, well, that breaker's there to protect that AC in the event of whatever. And if it's got a 50 amp breaker, well, when it's supposed to be tripping, it's not going to trip. And rather than tripping and protecting, it's going to let it burn up and cause all sorts of problems.
I got a picture right here, Mike, that we're talking about disconnects. Here's one. This is from one of my guys. I think it was yesterday or Tuesday that did an AC tune-up, and part of that is, I don't know if you want to share that on the podcast. That's what he came across. That looks pretty safe, doesn't it?
Nope.
What he's looking at is a picture of a wire.
I'm an electrician. I know that's not safe.
He's got a wire that it's completely fried and black and corroded and everything, and it should not look like that.
Wow. We'll put that up in the video. Text that to me. Okay, so after checking that stuff, we're going to check the condenser coil for damage and blockages. What is, again, just for those that don't know, what is the condenser coil?
Condenser coil is you've got your outdoor unit. It's the coil that is out there that's helping dissipate the heat.
Okay. Visual inspection of the line set. Inspection. Yep, that doesn't say installation. Inspection of the line set and AC for possible leaks. What are you looking for, and how do you know if there's a leak there?
Oil residue.
Okay.
That's one thing. Look, sometimes you can tell if the weld's not very good, or you see a hole
Down where the connections are, where it goes into the air conditioner?
If you look at one and you, especially, there's things that we go off of. You go off your conversation, you have a customer telling you, yeah, I got to get this thing recharged or get the gas put in it. It's pretty common people say, I got to do it every year. Well, when I get out there, I'm instantly looking for, like Richard's saying, oil residue at the joints, inside the unit, anywhere that there could potentially be a leak.
In regards to that, Kevin, some people think it's normal to have to add refrigerant to your system. It's not normal.
They think that refrigerant is like gas in the car. Like that's what makes the air conditioner run, and I got to get it refilled.
If it's done properly, you should never have to change or add refrigerant in your air conditioner.
Go ahead. Sorry.
I had a customer several years ago that had that scenario. Every year she would have a company come out, and so I went out there and I says, "No, you got plenty in here." And the problem was with where is it up here that we talked about, check the coil, but her coil was completely plugged up, so she wasn't getting that airflow. And so I'm like, we need to clean this, and then we need to remove. And she wasn't very happy. She's like, no, this other guy, it works. I'm like, look, just let's see what happens here. Just trust me. Let's do this. And in one of those situations, she's like, who do I believe? Mm-hmm. I'm like, look.
And just trust me worked.
Well, it was a little more in depth.
Just trust me.
It was a little more in depth. I gave her the price and said,
I'm just kidding.
If it doesn't work, I will not charge you this.
Got it.
So she had no worries because if it wasn't working. So I got it all done. And then I says, well, what do you think? She says, it sounds like I'm writing you a check. I said, well, if it's working better, she's like, it's never worked this good. But that adding refrigerant goes back to that coil. If it's not clean, it's going to show a symptom that it's low on charge. So there is some symptoms there that we need to know.
Yeah,
I like that. That exact scenario. I've seen it time after time, and it's amazing how much refrigerant I've actually pulled out in the past on some of these units after we've gotten them squared. And the thing that blows my mind the most about that is that every year there was a technician who went there and was willing to just put in the gas, mind-blowing to me because it's wrong.
Well, yeah, and the thing that I've learned over the years is that refrigerant, that's people think, it's not cooling, I need more refrigerant, because I think people think that in their car as well. But too little refrigerant and too much refrigerant can have similar effects where it's not cooling properly. Okay, so let's see. We've got test 24 volt control voltage at AC. Why are you testing that?
Making sure it's getting full voltage out to the air conditioner.
So you're testing out at the air conditioner. Is there 24 volts? So I'm assuming you're testing the proper function of a transformer somewhere?
Yes.
Okay.
Well, we do that as well.
Okay. Let's see. The 24 volts, that's the control voltage coming from the thermostat. Is that right? Or like some type of...
It originates in the furnace.
Okay.
You got a transformer there in the furnace, and then it sends a constant 24 volts to the thermostat, and it just sits there till the thermostat decides, hey, I need cold, or hey, I need hot. And then it sends that 24 volts wherever it needs to go. In this case, out to the condenser to tell it to turn on.
Gotcha. So is it sending the signal the entire time that the thing is running?
Yes.
So it's closing a connection, sending that voltage, and then when it gets to temperature, that opens back up, and that tells the system to stop running. Is that right?
And probably should add, this is for a typical air conditioner. There's some different kinds out there that run on different types of voltage. Some of your modulating, communicating stuff is going to be different, but I'd say 98% of the stuff out there, this is...
But when we get out there, we identify that, and we're making sure that it's running, pulling
correct.
the proper voltage there. Okay, measure voltage across the contactor. What is a contactor, and why are you measuring that voltage?
No, it's kind of like a breaker a little bit. You've got power sitting at your air conditioner at all times, and when that voltage, that 24 volt that we just talked about, gets sent out the air conditioner, it sends that high voltage through what's called a contactor and some relays that close, and that power continues on through the air conditioner now. So we're testing to make sure you're getting the proper voltage on the side of the air conditioner.
So you're making sure you're getting the 24 volts, and then when it closes, you're making sure that you've got 240 volts there across those two.
Yeah, it's just an automatic switch.
Okay. Let's see. Outdoor fan amp draw. So the outdoor fan is similar. The amp draw is testing the same way. You've got a fan indoors, you got a fan outside, and you're making sure that it's not pulling too much amperage and working harder than it needs to. Now, what's the most common like failure on those? Like, do you see a lot of those go out?
Yeah.
The fan motors?
Yeah. Why?
They make a lot of revolutions. They turn a lot of times around. A lot of those are over 1,000 RPMs.
So do those get out of whack as well, as far as like, having a wobble or bearings going out?
Yeah, if you got an air conditioner sitting underneath like an eave or something like that during the winter, and a big ice cube falls and goes through there and hits a fan blade, it's going to cause it to be off balance, and it's going to wear and tear on those bearings. You got a motor that's out now.
I'll remind you of Kevin's story of last episode.
We were trying to forget that. We didn't want to bring that up, like in case PETA didn't hear the last episode, but they did hear this episode. Like, we're just increasing our
cut?
chances.
Objects.
I don't know.
We just
No,
had
we left it in.
objects,
But
rocks, and
objects,
stuff.
yeah.
No, they were grasshoppers. Big ones.
But I remember we'd stick sticks in there too and watch the fan blade hit the sticks and go ding, 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 ding. And we'd
it was
do
awesome.
all sorts of stuff.
People
So,
see that with
yeah.
a bike tire and the spokes.
Yep.
We do it in the fan, in the air conditioner.
Kids will be kids.
Yeah.
Or adults. Let's see, showing their kids how to be kids. Let's see. Okay, so after that, we got inspect AC fan blades for alignment and vibration. That kind of ties in there. Inspect the fan motor condition, braking balance and vibration. So are you just watching the thing move? Is that what you're watching?
Yeah, we're watching, we're listening. If you got one that's off balance or something like that, it could also cause your amp draw to be higher. So we are testing the best we can.
I know I've seen on older air conditioners, like if you've ever been outside, when it kicks on and it sounds like it's struggling to start up, it's like you hear the and then ding, ching, 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 and then it comes up to speed.
Yeah, that's not normal.
That's normal. Oh, that's not normal.
No, that's not normal.
Oh, I need you to come out to my house. I'm just kidding. So, but is there a ramp up period? Like, what should it sound like if someone's out there listening? Because I mean, it does. You hear the contactor make connection there, and then you hear the little buzz, and then the thing starts going. Is there a little bit of a ramp up, or should it just, like, what should they, if someone's listening outside while they're working in the yard and they hear the air conditioner kicking on, what's a noise they could be like, hey, there might be something going on?
If it's clanking, banging, you don't want to hear those.
There's a wobble, vibration in the unit. That definitely, but most of them should just start up just Just I don't know.
If
So you
hear
shouldn't hear a long buzz.
No. Some of the higher SEER air conditioners, and you'll know if you have a higher one because it'd be more recent. They do the fan spins really slow, and then it may need to ramp up at that point. But there again, my technician will make sure to walk you through that information.
something to remember too, when these things are starting up on your typical just a standard air conditioner, there's refrigerant and oil that's sitting there that it's having to kick on and move right from the get-go, right? And to get that compressor moving, it takes some power. Your majority of your power usage when these things turn on is right at the beginning when it's turning on, because it takes them. So you will have, I would bet the most, and if you hear noise on startup that just say you've been in the house for a while and you just hear something strange and it hasn't been there before, that's most likely going to be when you hear it, when it's starting
If your
up.
fan doesn't come up to speed within 3 to 4 seconds, you've got problems.
Okay, so and that fan motor is tied directly to the next thing that you're checking, which is the compressor amp draw. And then you've got a couple of things out there, FLA rating and FLA actual. Talk to me about those and what those are.
Those are full load amps. We're testing what the actual what it's pulling and what it's rated for. Same thing with an amp draw on a motor. There's what it's supposed to be and where it actually is.
So you've got the reading off of the compressor itself
Yes.
of where it should be, and then what the actual is.
Mm-hmm.
Let's see, the OHM compressor. What is that?
That's called ohm compressor. We're testing kind of like we're checking the resistance of the wires inside of the air conditioner. They're rated for so much. And if they're over that, then there's some heat damage, heat stress.
The dual capacitor. That was the part that Kevin was talking about earlier when we talked about there's a capacitor indoors. And you're saying inside where the furnace is, that's usually a single capacitor,
Yes.
and then outside it's a dual capacitor because you're kicking on both the fan motor and the compressor.
Correct.
Does the compressor have a motor in it, or is it run off of
It's its own separate motor.
It's its own separate motor. Let's see. Check refrigerant levels. Superheat and subcool. So now refrigerant is a big deal to people. So talk to me about what you're checking and give the basics of how you check that.
Well, we hook up our gauges, and there's going to be a temperature difference between our gauges, because all of our gauges are doing is they're giving us a pressure, which tells us the temperature of the refrigerant side. Okay, so we want a difference, and it depends on what that is how well it is.
Sorry, I just pertinent. Gives you a pressure and an associated temperature with the pressure.
Thank you.
Sorry.
So the gauges, it shows you the pressure, and then it translates that into
Yes.
that means it's
Yes.
this temperature.
So when he's saying a temperature, you're actually getting a temperature from your gauge based on the pressure that it's at.
Gotcha.
Right? Sorry.
Now, when you put the gauges on, now is the subheat and the supercool, or superheat and you're the professional.
You are super cool.
So I am. The superheat and the subcool, are you measuring, because you've got one line that's bringing the hot refrigerant from the house and the other line that's taking the refrigerant, the colder, the refrigerant that's been cooled off back to the house. Are you measuring both of those right there, and you're measuring the difference of how hot it is coming from the house and how cold it is going to the house?
So essentially, when it says subcooling, I'm taking a temperature inside, like you say, and I'm just seeing how much heat, how much temperature it's actually losing by the time it gets outside. And superheat is the reverse of that. I'm looking at outside and seeing how much it heats up. See, am I thinking backwards?
Make it backwards.
So, but that's essentially what you're looking at. Superheat, you're just seeing how much is heating up, and subcooling, you're seeing how much it's cooling down. And you'll use one of those, one or the other, primarily based upon your system and what it has metering wise. Which I don't know if you want to get into like super deep detail with that, but based on what you've got, that's going to be the first one you look at. But they're all indicatory of balance of where your refrigerant levels should be.
Liquid PSI and vapor PSI. What's the liquid and what's the vapor, and what are you checking there?
That's what Kevin was talking about. That pressure just gives us a correlation with the actual temperature, and it's just honestly for our records and for your records, so we can see if we come back next year and those have changed drastically, we gotta dive into why.
Gotcha. And then liquid line temp, liquid line temp. Oh, there's two of them.
Yeah, we got a misprint there. We missed that one.
An hour and 19 minutes. What's it supposed to be?
Vapor.
Oh, so liquid line temp, and so we're still checking all that same stuff, and then rinsing off the outside condensing unit.
Yeah. So essentially, the reason that you're putting those to check subcooling, that's what you're looking at, right? The way you get your temperature on the one side is through your gauge, and then you actually take an actual temperature and you just take the difference, right? That's how you're getting your subcooling versus your superheat.
Got it. So, whew, man, that's a lot of stuff. You guys have any last thoughts? You don't have to, because you've shared a lot.
No, that's our tune-up sheet. That's a lot that goes on. That's how come the manufacturer says get a licensed professional out there. There's a lot on there. There's a lot of knowledge. There's a lot of tools, specialty tools that we have. So,
well, thanks so much for listening to this episode of In the House. We'll be back next Tuesday with a new episode. If you've enjoyed the show, please subscribe. Do me a favor. If you've got time, go to iTunes, leave a review for the show. Let us know what you think. I'd like to thank my guests, Kevin, Dustin, Dick, for being here, Austin for co-producing in the background, and everybody else behind the scenes that helped to make this possible. If you'd like to know more about Any Hour Services, go to anyhourservices.com. I've been your host, Mike Wilson, and you've been listening to In the House. See ya.